Potential question, how do I graph a system? Or, yeah, how do I solve a system by graphing? Okay, first off, the solution to a system of equations is the x and y. That's not clear. It's a point, right? Because it's where the lines intersect. X, y, that makes all of the equations true. Specifically, we're only going to see 2 equations in our systems, but you could have more. Oops. We saw that yesterday when you plugged in the point where they intersected. It was like 2 equals 2 and 2 equals 2. So it made both of the equations work. It made both of them true. When we solve an equation in one variable, we get one answer, like usually for x. But now you're getting 2 answers, x equals 1 and x equals 3, or y equals 3. So you get 2 variables, and you can answer for each. To find the solution to a system of equations graphically, you're looking for the intersection point, right? We talked about that yesterday. You want the point where the 2 lines intersect, because that's where x and y are the same for both equations. We talked about 3 types of solutions yesterday. Colby, what are they?
One solution, no solutions.
Great. Infinite solutions. Your one solution, again, should be written as a point, x, comma, y. Yeah, Micah?
I noticed that
I've graphed my 2 lines. Remember, you always go rise over run, vertical over horizontal. If the slope is positive, then it's going up and then to the right. If the slope is negative, then it's going down and then to the right. I wrote out my slope and I wrote out my y-intercept so I don't mess up something small. I know you know how to graph lines. This is really important. So Xander, what's my solution? Where do the lines intersect?
At 0, 2.
Try x, y. 2, 0. There you go. X, comma, y. 2, 0. That would be this point right there. We write down the point. When we do systems of equations, you write your answer as a point. This means the same thing as saying x equals 2 and y equals 0. You have solved 2 equations at once, which is great. And then important things to notice. What do you notice about their slopes? Are they the same or different? Different, right? In order for them to not be parallel, their slopes have to be different. So let's write down that our slopes are different. And that they cross one time, right? They have to cross exactly once, because that would give me one solution. Okay. Why are these lines no solutions, Owen? Right, they never touch, they never intersect, because why, Mira?
They're parallel.
Bingo. They're parallel lines. So we're going to say our solution, you have to say these words. Hello. Let's try that again. No solutions. And if they're parallel, then what do we say about our slopes, Elizabeth? Right, same slope. Sometimes I'm going to try to be a little bit tricky and make it look like they're different slopes, but they're just written in different ways. Pay attention to that. So the same slope. There's something else that's important though. Pierre? Bingo. Different y-intercept. They start at different places, but they go the same steepness, so they can never touch. Okay, one more. Infinite solutions, which I have not graphed yet, so let's do that really quick. I start at 1, and is it negative or positive?
Negative.
Negative. Nice. Negative. Go down 3, right 1. Whee. That's line A. Emily, what do you notice for line B?
It's the same equation as line A.
But I see 6 over negative 2.
Same thing.
Right. Simplify the fraction and you get the same thing. Y is equal to negative 3x plus 1. 6 divided by negative 2 is negative 3. You really don't need to graph another line, although you could. You could just like make a point and be like, oh, they're overlapping. So, Nancy, what's my solution?
Infinite solution.
Yeah, and this should say, Micah's right, this should say type 3. This is infinite solutions because the lines are overlapping. They're the exact same line, and so they are going to touch at every single point on that line. Every single point on the lines works. Important things to notice, everything is the same, right? I think we get that one. So check your slopes and see if they could simplify to be the same. That's what you want to look for. Okay, and then looking at these, this is what I'm going to need you to be able to do. On your homework, on the front, it asks you to actually write equations, like come up with equations that would be infinite, no solution, one solution. So to summarize, it's going to be one solution if they have different slopes. It will be infinite solutions if they are the exact same slope and the y-intercept, and it will be no solutions if they have the same slope and different y-intercepts. Okay, I want you to go through these, A through F, and write by each one, infinite or no solutions. Quickly, go. Okay, for the sake of time, I've highlighted the things that are the same. Catherine, what should I say for A? There is one solution. Why? Yeah. Different slopes gives me 1. What about B? It looks like they have the same slope. Emma, what should I say?
None.
Why?
Because the y-intercept is the same one's positive 2 and negative 2.
Right. Same slope, different y-intercept. That will give me no solution. Julian C.
Infinite.
Why?
Because the slopes are the same and the y-intercept is the same.
Right. Everything's the same. It's written a little bit differently. 3/4 is the same thing as 0.75. D. Xander?
One solution.
How do you know?
Same y-intercept as equal.
Right. It doesn't matter that the y-intercept is different.
Different slope.
Different slope is going to give me different steepness, and so they will only cross one time. Luke, how about E?
0 solution.
What's a better way to say that?
No solution.
Okay. Well, 0 is good, but you guys getting emails? No solutions. Why, Luke?
Because the slope is the same, but the y-intercept.
Cool. And then the last one, F. Finn?
No solution.
How do you know?
Because they're parallel.
Okay, visualize graphing this. Y equals 8. I guess that would be like y equals 10. Y equals 8. That's not a very good parallel line. That's mildly better. Right? They're horizontal lines. Horizontal lines have a slope of 0 and are y equals a number. Those are horizontal lines. They will never touch. This is no solutions. For ones like that, I would suggest graphing a little picture. You could do that for all of these. I don't really care. But you need to know based on recognition eventually.